Hello, welcome to a technical presentation for the project team, House Abstraction Layer. The following team members are Josh Kozak, myself, Simrat, and Scott Herr. Scott will be later on in the video explaining the VPN as well as some of the honeypot and networking that we've done. But let's get started right away with Simrat going through our web interface.
Hello, hi, this is Simrat here. So I will be explaining the user login and user creation part for this system. As you can see here, this is our website. This is the main management interface for our system. So for now, let's first create a new user. So if you just click here, this website asks for the secret passphrase. This passphrase is given by the technicians once everything's just sets up. So for default it's password. So if this secret passphrase is correct, new user details are added. So let's just create the username capstone with default password as password. As you can see, the user has been added successfully. So let's just log in using that user. So in case anyone tries to access this system without any valid credentials, let's say if we try to access this using capstone 2, the system restricts that one, saying invalid user credentials. Yep, it says invalid user details. So let's try with the actual one. The username and password for this login credentials for the users are stored on a MySQL database, which are all encrypted into #256 algorithm, which is by default in PHP. So it takes data from here, encrypts it, and then stores it on the MySQL database. So there's a great security in this one. As you can see, we have successfully logged into our web interface. This is the main interface that the user have, and from here you can control your GPIO pins, your thermostat, and your Philips Hue. For first portion, from this section we can control our GPIO pins that are located on the Raspberry Pi. So this is an image based control. If we can, as you can see now, the red means these all GPIO pins are turned off. If you can just click the image, it turns green, signifies that the light has been turned off on properly. Same we can do from the other light as well. And yep, turning it off is also easy from here. And the next section explains that from here we can set the schedules for these lights to be turned off. Let's say if we want the lights to be turned off at 6 p.m. we just click 6 and then we hit submit. Yep, so at 18, which is 6 p.m. the lights will be turned off. This creates a schedule for the lights to turn off. If we go to main page, the next portion we will be explaining is the thermostat. So I hand over to Josh to explain that part. So Josh, if you can just continue from here.
Yeah, of course. Thank you. Well, we're just going to go through the web interface to interface with the thermostat. We've got the thermostat here so we can see the display, and then to simulate the furnace we just have a light bulb that's going to turn on and off, as the thermostat would basically just be doing the same thing with your furnace. So first we're going to see that we get down to that section. It's going to give you the current temperature of the house, which is going to take the temperature constantly updated every minute from the internal thermostat, or the internal thermometer of your thermostat. Then we're going to move down and you can see the current status of the furnace, whether or not it's running, and from there you can turn it on. So we're just going to go ahead and turn that on right now. And as you can see, we then have I'll move the light out so we can get some better view. And now we have a second number under our thermostat, and that should read as our current set heating point. Now we can also manipulate the current set heating point, and as it's higher than what the current temperature is, it's going to have the light on. So we'll bring the light back here, and then we're just going to drop the temperature down below where we currently are, so the light should automatically turn off. All right, and we did have that light turn off once it got all the messaging protocols through. Then we scroll down to the next part, and we get to set a time when our furnace will turn on, and that'll merely just set up a job so that it'll turn the furnace on an hour or so before if you want to have the house heated when you get home for you. We can also then go to the next section, and we see that it's the status of the furnace filters, so you can just plug in when you change them, and it will update you after 3 months to let you know you should be changing your filters. All right, and look at the Philips Hue part of the web interface as well, so that we have the part where we can connect to the Philips bridge. And then once we're connected, it will show us in the next section what currently is connected and the status of those lights. Then we get down a little bit more, and as you can see, we can turn the lights on or off. And as we're currently using the light right above me, we're just going to go ahead and turn that off, and we should see that happen as well. Awesome. Now we get down to the final part of the Philips Hue, not just the schedule actually, and we're going to manipulate the brightness of our light. So we're first going to turn it on, and then we're going to set it to about 50%. So we should see it go to full brightness and then dim a little above me. All right, and as we can see, it's got some light, but not full light anymore. So we're just going to look at the schedule for the Philips Hue. We can go ahead and click on that, and then that allows us to set up some times for when we would like the lights to automatically come on or turn off.
So thanks, Josh. So for the scheduling of the lights, as you can see here, this is the main scheduling page of the lights. So as of now, we can just see there is only one schedule time that has been enabled. The status says it's enabled. So we can delete this if we want. So if we just click delete the schedules, as you can see, it says the current schedule, and we click here, all the schedules will be deleted by default. Yep, so it says no schedules are set. To set any schedules, we just click here, set new schedules here. It takes you to a new web page with ask for what the name you want. Let's say we want the name capstone for this project, and we can select the light. So for this demonstration purposes, we only have one light attached to our web interface, so we have to use light ID 4. We can set the time, let's say this one, the month, we choose this, and let's say it's 15th, and we want the light to be turned on at 2, let's say 2 a.m. and we just select the action and just click on purpose or submit. As you can see, it says schedules has been set. We can just confirm that one. Yep, the capstone says here the description, the status. The command portion of this page says it's on, so it means that the light will be turned on at this scheduled time. Another thing on the web interface is that the web interface can be used to connect with the Philips bridge. So if you can just click here, it takes you to the web page in which you just need to input the third quadrant of the IP address. So if we just put 50 here, which is the actual IP subnet for this, where the Philips bridge is located, and if we hit submit, and this web page should scan the whole network and then will connect with the Philips bridge that is located. As you can see, the Raspberry Pi has been successfully linked with the Philips bridge, and that's what you need to on the first time. We recommend that once doing this connection with the Philips bridge, the link button on the bridge should be pressed, so just to be sure of the connection. Let's just explain our logging service of our system. As you can see, I have SSH'd into a log server that is located on the other end. So if I just log server here, so this server collects all the logging information from the web interface. If you see here, there are two files which says log fail and log success. If you just look into the log fail named file, it says that Capstone 2 tried to log into the system, which we just demonstrated before, and the other file should say that the successful logging of the interface. As you can see, the Capstone successfully logged into the system on this date. This information is stored on a separate server to avoid using more space on our web server, which is the Raspberry Pi. So that's the logging service of our system.
This is the pfSense dashboard. This is where you can go and configure everything on the pfSense. So I'm just going to show you a couple things that we have configured on the pfSense. So on the pfSense, we have a couple services running. So we have a DHCP server running on the pfSense, and it has two different interfaces. This interface, option 1, is for the honeypot, and it provides addresses to all of the devices on the honeypot. On the honeypot, there is Windows 10 Honey 1, Windows 10 Honey 2, CentOS Honey 1, and WinServer Honey 1. On the LAN, this is where all of the actual HAL devices are. So this is where the database server for the website is hosted. This is where there's a DNS server, and this is where there is the pfSense also has an address on here, and this is where the VPN gives access to this interface. There's also some firewall rules configured in here just to block incoming, like, SYN floods and stuff like that. Then we also have Snort configured on this device. So we have Snort configured on here to basically monitor what is coming in. So we just have a couple Snort rules configured to monitor what is going to happen and what will, and alert us if there's anything potentially wrong happening to the network. If there's anything coming in that shouldn't be coming in, it will monitor us and it will tell us on the dashboard. So here, I'll just use this. We have the VPN traffic detected, this guy. So this just detects whenever somebody has logged on through the VPN. If I go back to the pfSense. So if I connect to the VPN now, you'll see that it will, once the VPN has connected, it will show up that on the WAN, there has been VPN traffic detected right here. So we can see that this VPN has connected from the specific address here, and we're trying to gain access to that. Yeah, so this is where the VPN is connected. You'll see that the address used is the address of my current computer that it's connected from, and then it will replicate that back and give it an address from the VPN itself. So for the OpenVPN, we have a server configured, and this server configured gives access to this tunnel network. So this is the tunnel network that the Raspberry Pi at Josh's house connects to through the VPN. Now on our server, so this is our server computer now, we have a couple VMs on here. So we have this DNS VM. So this VM has forward lookup zone, back, and a reverse lookup zone for the HAL area, for the HAL zone. So in here I just included the lookup zones, or specific names for the pfSense LAN IP address, the DNS server's IP address, and then the database server for the website's IP address. Then this is our pfSense VM. So this is what we are configuring through the dashboard, through the web interface. Then this is the database server VM. This just hosts the database server for the website and for user IDs and passwords. Then these are honeypot VMs. So this is just a Windows 10 VM. Just taking a second to wake up. This is just a Windows 10 VM to look like a user. Just a user on the network. It's just a normal Windows 10 VM. Then this is a CentOS VM, and this VM has SSH running on it to make it look similar to the database server VM that we're running on the HAL network. Then this is our Windows 10 server, or Windows Server 2016 VM that is designed to look like the DNS server running on the HAL network. So it's running a DNS, it's just running the DNS servers, and that's basically it. So all of these VMs are being run on a server at Scott's house, and the server at Scott's house is it's running in RAID 1 for potential hardware issues that might arise, so that we don't have to worry about losing all of our data.